Last call for answers. What do you got there answering? Okay. Not bad. How'd you do this? Take a hand. Okay, down after.
First thing you do is look and see if it's a geometric or other arithmetic sequence. And because if you were to take, let's say, -24 and divided by -4, you could see that the values are being multiplied as they're going on, they're not being added or subtracted to. So you know it's geometric. And the final calculation you provide a term, and -24 divided by -4 is 6. And now you use the function for the sum of geometric sequences to find the sum of geometric sequences. So it'll be the nth sum.
The sum of the first 7.
Okay. Sum of the first 7 terms is equal to -4 times quantity 1 minus 6.
7.
7 divided by 1 minus 6.
Very good. Hardest part probably is either figuring out if it's arithmetic or geometric, and then making sure you find the common ratio or common difference correctly. Questions on that one? Guess that's what we did yesterday. Who else was absent yesterday? Talia? No? I forget who else. That's what we did yesterday. Got all kinds of ugly writing here. Okay, if there's no questions, number 2. Okay, let's draw. Okay. Good. 25, 6. I'm fine with that. So if you did want to use the equation, I think it's 7 plus 6, 7 minus 1, and that would also give you 43. Good. And then the sum of the first 7 is equal to 7 times 7 plus 43 over 2. So this is 50. 7 times 50 is just like 7 times 5. So 35, 350. Divided by 2 is 175. Yeah, look at the difference between arithmetic and geometric. Arithmetic requires 2 equations to find the series, the sum of all the terms. Geometric's a little bit easier in that you only have to do 1 equation. Okay, today we're going to do basically the same thing, but I'm going to throw in some new notation. So it's just going to look a little bit different. Take your warm-up, set it aside, and look at today's notes in 10, 9, 8, 7, 6, 4, 3, 2, and 1. All right, maybe I should zoom in a little bit here. Here's how we read this. The sum, so first let's talk about this letter. And you should be able to pick up on the fact that this letter's name is sigma. Sigma is a Greek letter. So English is not the only alphabet in the world, right? Russian has its own alphabet, Chinese has its own alphabet, and Greek has its own alphabet. So capital S looks like this. A lowercase s in the middle of a word looks like that. A lowercase s at the end of a word looks like that. Kind of see how it looks like our S, can't you? But it's got a really small curlicue here.
Hey, look at that stuff like it's dope.
Yep, they sure do. Same thing. So, one of the most, oh my goodness.
Is your pen messing up?
I'm trying to figure out if my pen is moving at all.
No, yeah. Chill it out. You been messing with me all day. Give it up.
What is it? Hold on, wait.
Something with everything.
That's an I in
Bonus points to anyone who can figure out what that means in English.
Sigma notation.
No.
No, because it's
So
like
they know
it's
X
right
right
there.
there.
Yes.
Kevin Matisse.
Nope. But look how many sigmas it has. It has 4 sigmas.
X, Sigma, X.
Sigma's a letter, and it's like our S.
Is that an I and an N right there?
So Sigma means S.
I know X, Xi.
Now think about it. If sigma means S in Greek, and we've been doing 2 different equations, one of our equations starts with A, right? And the other one starts with S. So yeah, these are still series. This is still the exact same thing as a series. So what that means is you're going to take all the terms. It's not.
And have 2 X's.
You know,
I don't even know where 2 X's.
Let's start with S.
I'm in no hurry. What I'm trying to do is give you a little mental bridge here that this is still an S, and so we're still doing a series, which means we're going to add up all the numbers. Okay, so here's what this means. The sum, as we go from the first term to the 7th term of n. So let's find out. Let's find the first 7 terms. So 1, 2, 3, 4, 5. Go ahead, write this on your paper. We're going to find the first 7 terms. Hopefully I'm not going to insult your intelligence here too much. Because we have a very basic function. Remember, a function's like a microwave. You put the little kernels in, and then 2 minutes later, out comes buttery popcorn. So you put one thing in, and you get something else out. Although for this one, it's pretty darn simple. If we plug 1 into the function, the first term, if we plug that into the function, we get 1. If you put 2 in for n, you get 2. Don't overthink it.
N equals
3.
3. 3, 4, 5, 6.
So this function is so easy. All you do is whatever you plug in is whatever you get. You know, a lot of functions are going to say 3n minus 8. So you'll plug in 1, multiply by 3, subtract 8, and that's the term. This one's so easy, though, that it's just you plug in, and whatever you plug in is what you get. Now, since it is a series, we have one more step. Loriana?
It is equal to 1 every time?
No. I don't know what you mean by that either.
We do it geometric.
You showing me that 1 is like N equals 1.
Oh, usually it'll start with the first term. It doesn't have to, though.
Do something like that.
Now, since it's a series, that means you have to add up the terms. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7.
I did about 3, 6, 10, 15, 21, 28.
That's the answer. 28. Look at number 2.
Is it?
The sum as we look at the first to the 6th term of 3n plus 2 equals, well, let's figure it out. We got the first, second, third, fourth, fifth, 6 terms. We got 6 terms this time, not 7. Why 6 terms? Yeah, this one at the top tells me which term to stop at. This one tells me which one to start at. So to find the first term, all we do is we take 1, plug it in for n. So 3 times 1
5,
is 3 plus 2 is 5.
6, 8. Is that? 14. 17. 20.
Now, I need you to have a light bulb moment here that this coefficient of n tells you how much we step up each time. Can you see that? Can you see that every step we increase by 3? Why? Because the coefficient of n is 3. What if the coefficient was negative 5?
It'd be negative 5.
It would get smaller by 5 every time. The common difference is the coefficient of n.
This happened to me anytime.
So we really don't have to.
Now to finish the problem, what do I need to do? Add them together.
35.
Oh, that was fast.
Go play. Type it in my head. Something 5, 6, 7, 8.
Now think about it. Is it that hard to write a computer program to do that?
We still ain't found that word.
Press the format button.
No, man.
Find your sigma.
We really need it though. So easy.
Some of them will get.
You finna show us the easier way to do it. It ain't gonna be X or
Nope. As n goes from 1 to 7.
I see it.
All I'm doing is the number 1. What goes in the parentheses?
So we just put it in the calculator, put the answer down, right? Go play. Put it in the calculator, go play. You know what I mean?
Put it in the calculator. Don't need you to announce your hands. I'm gonna keep reminding you that. Y'all gonna look so goofy in college. Doctor. He's gonna be like, why? He's gonna be like, don't worry about it. He'll be like, maybe you can talk to me after class.
Don't worry about it. I ain't gonna be here. Don't worry about it.
Good luck graduating. Lawyer. Write it down and box it. All right, now, before you get too caught up and speed away with all these easy ones here, look down at number 9. Okay. And make sure you look at your directions carefully. It says write each series in Sigma notation.
Oh.
Slow down, slow down, slow down, slow down.
Shit would have a heart attack.
What will not like this sign?
Yeah, Chris.
Okay.
Is E on all 6 1?
What is that?
They want you to start the first turn and then you get it. Okay. No, I'm saying like if you're doing it like this.
You'll need to raise your hand.
Okay.
Now, whatever the common difference is, that's, like we said earlier, that's the coefficient. So the coefficient here is 6. Now, if you plug 1 in, you're going to get 6, not 15. So all you have to think is this. How do I get from 6 to 15? Add 9. Let me say that again. You know it's got to be 6 in. Why? Because the common difference is 6. It's plus 6 every time, so it has to be 6 in here. Now the question is, if I plug in 1 to find the first term, 6 times 1 is 6, but that's not the first term. The first term is 15. So how do I get from 6 to 15? I add 9. Sometimes it'll be subtract 50. Sometimes it'll be minus 18. Could be anything. You can type that into your calculator. You can use your tab button to cycle through these empty boxes, by the way. When you box this, I want you to box your whole answer. Now I want you to notice something. Is there any difference between this problem and number 2 on the warm-up?
No.
Exact same thing. So now you have one more option on how to find a series. This is a series. This is the sum of the first 9 terms. This is just like this problem right here. It's exactly like it. So now you have one more way that you can solve this. All right, at this time, questions.
So does it matter if it's geometric or arithmetic?
Of course it matters.
I'm saying like would you use those values or just
You're not going to do 15 through 20.
What are you doing, conversation?
Pointless.
It's too hard.
No, it's just not our material, it's not our curriculum.
It look like the same thing.
You can figure it out.
It's trick.
that's geometric.
Sure. All right, you do number 10. I'm going to quick pull you. Question, Jay. Yeah, what's your question? Bring up the calculator. Number 10 right now, number 10. You and scratch plate.
I know which one it is.
They don't know before like that.
Trying to get some money, make that money.
Or did I supposed to put in one?
You typed it in right. That's correct.
Maybe you answered well.
Who is it? Who else? Who was getting something else? Let me check something, JJ. Yeah, mine's giving me 254 too. Something else. Yeah, 250. Yeah, 254 is right for number 4.
For number what?
4.
254.
Okay, bring your calculator. Who's getting a different answer?
I got 39. Let me do it. Let me do it. Number 3. Number 3. Yeah, 5.
Yep, you're doing number 10 right now. Number 10. Okay, on the quick poll, just type in your final answer. Don't type in the Sigma notation. Tell me that's great. That's great Sigma notation. Just type in your answer. All kinds of crazy answers.
I find an answer to be a decimal right? For a fraction.
For number 10,
Now I'm talking about
yes. Leave it as a fraction.
leave it as a fraction.
All right, here's what y'all said. All kinds of crazy answers.
Because if you put one for n, it's gonna give you 10, so you have to.
It's gonna give you what?
I mean, it's gonna give you 10, -10.
Negative 10.
So you have to subtract 19 to get negative. You gotta add, subtract negative 29. From negative 29, you get negative. They get negative 29. What? You add it for negative. You got where you get 8 was the first one? Because eight is lower term.
Okay, 8 is n.
Oh, guess what term you going to? You going to the 8th term.
Okay, n.
Okay, if you plug in 1 for n, you're gonna get negative 10 times 1 is negative 10. And then you get negative 29, you have to add negative 19.
So
So you subtract 19. It's negative 10 times 1 minus 19. How'd you get 19? Because 10 plus, I got 10 plus 19, you have to subtract 19 to get you negative 20. How you get 19?
how far is 10 negative 10 from negative 19?
You
What's the
can't.
difference?
It's nine, though. Negative nine. No, it's not. You said how far is negative 10 from first? Oh! It's negative 9. Man. It's me.
Alright, let's practice. Remember, don't do that certain section where it says G. Actually, no, my bad. I forgot exactly what I was going to tell you. Good, that gave me enough time to process that.
I got him thinking.
Y'all got me thinking. Appreciate it. So, this section right here, I'll go back up.
What's good?
Y'all are quite panicky today.
I want you to do it.
No, you do.
Nah.
She told me to.
You did tell me about it. I was just gonna do it straight. Something big dog. You did to a big dog. What we doing?
So we gotta do this now.
Ain't that what you said? I thought that what you said.
Don't worry about it.
Don't worry about it. Don't even worry about it. Don't do it. Don't get zero. Don't worry about it.
So don't write your signal.
15 through 20, just do like you have been doing.
Right down.
Like we did yesterday.
Right down. Hard.
Why? When we doing Sigma Notation?
Because you can't really do Sigma notation with those. Or I don't want you to do Sigma notation with those.
Him and I. Great.
Man, I can't let the student become greater than the master.
Yeah, I hate it. They really tell me.